Hi, welcome back to Moose and Chemistry. Today's lesson is Chemical Reaction Notes Lesson 1. In this lesson, we're going to talk a little bit about what are chemical equations. Okay, first of all, you have something called a chemical change and a physical change. So, a physical change is like solid to liquid to gas to plasma. However, the substances are not being changed. Just their physical states are, okay? So you're not making new substances. So we're not going to be talking about physical changes. Okay, that has nothing to do with a chemical reaction. A chemical change is where you create new substances that are different from the old ones, okay? So we're going to be talking about a chemical change, not a physical change. So let me clear these drawings. Okay, so now chemical reactions have two basic components. You have something called the reactants, and you have something called products. Reactants are elements or compounds you start with. Products are elements or compounds, or new compounds, for example, you end with. So what I'm saying is that reactants are different from their products. So reactants are different from their products. So in essence, what we're saying is that reactants create products. So, in this case, atoms are rearranged, but they're not created, nor are they destroyed. Because remember that you cannot, and I repeat, cannot create or destroy atoms in an ordinary chemical reaction. So, yeah, you could do that in nuclear reactions, but in chemical reactions, you can't do that. So, let's clear this board here real quick, and let's see basically what kind of reactions would you see. One type of reaction would be like, let's say you have magnesium iodide, right? And we want to add fluorine to that. So can fluorine replace iodide? And the answer is it can. So this would make magnesium fluoride plus iodide. So that's what type of reaction that you would see. This is a reaction that deals with symbols. The other type of reaction you might see, and we'll do this in a word equation. So we would say something like fluorine gas is combined with magnesium iodide to form magnesium fluoride and iodide gas. Now this is called a word equation. Okay. The last one you saw, this is called a chemical equation. Okay, so when you look at the word equation, you say fluorine gas. Okay, that's F2 is combined. Is combined means plus with magnesium iodide. Let's see here. So you're saying that fluorine is going to replace iodide, which it will in the activity series. This creates magnesium fluoride plus free iodide gas. Okay? And then again, you can see this as a chemical equation, or you can see this as a word equation. Now, there are also things called symbols. There are certain symbols, and like for example, let's go ahead and clear these drawings again, and we'll talk about the symbols that you might see in a chemical reaction. All right, here we go. For example, we'll just call this a symbol. Okay. If you have a plus sign, that means, okay, this is what it means, separates reactants or products. This means, this arrow sign means both yields or forms. That's what it means, yields or forms. Okay? You might see this symbol. What that symbol tells you that this is a reversible reaction. And then in this reversible reaction, what you're saying is that the reaction is going forward in the to the right, or it could be going reverse to the left. Other symbols that we've talked about in the past, things like this means solid. That means the compound or the element is solid. This means that it's in the liquid state. This means it's in the gas state. And of course, this means the aqueous state, which is a solid dissolved in a solution. Okay? So this aqueous state. Now, a couple other things that you might see under symbols. All right, so let's clear all these drawings again. Get some more space here. So we'll call these symbols again, and their meaning. If you have an up arrow, that means that a gas was produced in your chemical equation. If you have a down arrow, that means a precipitant. Or precipitate, which is a solid, was produced. Another symbol that you might see, it might look something like this. Or it could look like this. This means that heat is added. Okay? You might see something like this, a symbol with say PT in it, an element. That means a catalyst. Now remember, catalysts are used to speed up reactions. They also lower the activation energy, which allows the reaction to occur. Also remember that a catalyst is not used up in a reaction, and it is not created, it's not a reactant, nor is it a product. Now, a couple other things we want to talk about. So we're going ahead and clear these drawings here. And again, this is all just kind of basic information on chemical reactions. Now, when we're talking about the equations, the first thing you may write in a chemical equation, you may write something like this. Let's see here. How about, let's make it pretty simple. Calcium phosphate plus lead nitrate yields calcium nitrate plus lead phosphate. All right. Now, please notice that I've used formulas and I've used some oxidation symbols. I've used plus signs and a yield sign, but hey, guess what I'm not doing? It's not balanced. This is what we call the skeletal equation. Okay? So we take skeletal equations and then we will balance them. So, and there are a couple balancing rules. So balance chemical equations, okay? And we'll come back and balance that equation, of course. Okay, there are 4 basic rules for balancing chemical equations. So when we're balancing chemical equations, first of all, write the correct formula for products and reactants. Okay, then basically you're going to use your oxidation numbers to help you to do that. The second thing you're going to do is you're going to count the number of atoms of each type on both sides. So in other words, remember I told you about the table method. So you're going to want to set up, like, so let's say this is H and O, this is H and O. Let's say we have the equation H2 plus O2 yields H2O. So you want to set it up like this, so you know that this is 2, this is 2, this is 2, this is 1. So now, you can't touch the subscripts. You can only balance using the coefficients. So to balance this equation, of course, we would put a 2 there, which would give me 2 here and 4 there. So you would have to put a 2 there, and then you would have 4, 2, 4, 2. So remember, you balance using the coefficients. The coefficients are the numbers that you put in front of the element or the compound. The subscripts, you never touch these guys. Those are the things that are below the elements. All right, now we have that. Let's go back and look at our original equation. So I'm going to need to erase these rules to give me space to balance this upward equation. So let me go ahead and stop here for a moment. Okay, so now, using those rules that we have, let's see here. First, look at this. We have a 2 here and a 3 there. So we want to crisscross these guys right here. We want to do the old crisscross method. So we're going to put a 3 here and then a 2 here, but you're going to need a bracket for that. Oh, look, we're going to have to crisscross again here. So we're going to put a 2 here. Now that 1 goes there, but we really don't put a 1 there. All right, let's look over here. Oh, we're going to have to crisscross again here. So we're going to put a 2 right here, because you know that's a -1 charge, by the way. And again, same thing here. We're going to have to crisscross again here. So this is going to give me a 3, and this is going to give me a 2. All right, now we're looking at this equation, and we're going to want to set up a table. So again, remember, we're going to set up the table there. And we're going to go, okay, Ca, P, O, P, whoops, PB, and N. Oh, I see an O again, but I'm not going to write it again because you only give it one time. All right, over here, we're going to go CA. It doesn't matter which order that's in. We're going to write in the same order as we do on the left to make it easier. P, O, P, B, and N. All right, we have 3 here. We have 2 P's. We have 8 O's here, and 6 O's makes 14 O's. We have 1 PB, and we have 2 N's. Over here, we have 1 CA. We have 2 N's. 6 O's plus 8 O's make 14 O's. We have 3 PBs there. And we, whoops, in the wrong spot there, sorry. We have 3 PBs there. And we have 2 P's. All right. So our P's look good, but our PBs don't. So we're going to have to work some magic here. So let's go ahead and let's place a 3 in front of here to satisfy that. And of course we're going to have to put a 3 in front of here because of that PB. So now let's see what that does. Okay, when we do this, we get 3 PB. Let's make these lines a little bit longer. We may need some space on this one. I'm not really sure. Okay, let's make the lines a little longer here. All right, so this gives me now 6 nitrogens. This is 6 oxygens times 3 is 18. 18 and 8 make 26 oxygens. Okay. Okay, so that's that. All right, let's look what we did over here. We put a 3 in front of there. This gives me 6 nitrogens now. That's looking good and promising. This is 6 times 3 is 18. Plus 8 gives me 26 oxygens. And let's see how it looks here. We have 3, 2, 26, 3, 6, 3. 2, 26, 3, 6. Yes. So we have 3, 2, 26, 3, 6. 3, 2, 26, 3, 6. So this equation is perfectly balanced. Okay, there are just a couple of things that you never do. Remember, never, ever, ever, never balance / change coefficients. I mean subscripts. Okay, and the second thing is you never put a subscript, for example, let me show you here. Let me erase this real quick. That's one thing you don't do. When you start balancing these chemical equations, you can't change the subscript. You can change the coefficient all day long, but never the subscript. The next thing you can't do is you can't write something like this. And watch this. You can't do this. Ca3 2PO4. You can't put subscripts in the middle because then they look like coefficients. So you don't do that. You cannot do this. Okay? It has to be written as Ca3PO4 and of course 2 for that. Let's make that C a little bit better. I don't like that C. It kind of looks like a messed up looking C there. But anyway, so these are the basic rules for balancing chemical equations. And we'll see you back again on Moose in Chemistry. We hope you have an awesome day.